Let's see the simplified version of stresses in the ground. I think I talked about this particular case. We have the total stress and the pore pressure, and you will get the effective stress. Please note that the pore pressure is hydrostatic. It is the same in all directions. So if I am looking at a small element, I will get the normal force here in the vertical direction, and this is the normal force in the horizontal direction. So I can have a vertical stress, total stress minus pore pressure gives me the vertical effective stress. Similarly, I have total horizontal force or stress minus pore pressure gives me the net horizontal effective stress. So here is the simple principle of effective stress. Total stress is equal to effective stress plus pore water pressure, or effective stress is equal to total stress minus pore water pressure. All soil behavior is controlled by effective stress only. This is something I talked to you about, capillary rise. Suppose the groundwater level is here, which means it's atmospheric pressure, and if I put a soil column here, the water will rise from the groundwater into the soil because the void size is very, very small. Please remember, the void sizes can be as small as even 1 micron, which means being a capillary tube, it can go higher up. The degree of saturation could be close to 100 at the groundwater level. As it goes up, it can decrease. And finally, you may get the hygroscopic moisture, which is usually 5, 10, 20%. The amount of capillary rise varies based on the type of soil. I have coarse gravel, and if I look at D10, the 10% finer, it's very high. So I'll have only 0.82 as the size D10, void ratio is 0.27, and the capillary rise is only around 5 centimeter. Look at silt when you got clay, where the pore size is very small, the capillary rise can be as high as 3 to 4 meters. It's also interesting that if the water level is here and is falling down, you will have one line, whereas if the water level is here and it is rising, you will have another profile. Another important point I would like to mention is the pore water pressures will be negative because here the total head is 0, and as you move up, the elevation head is increasing, but the total head is remaining same, so the water pressures will all be negative. That we call as capillary negative pressure, and that means the effective stresses will be more because sigma minus u, which is negative, gives me a very high effective stress.